At 5:24 in the afternoon on May 5th, 2026, 9 hours after episode 46 began and 7 seconds after it ended, the USGS Hawaiian Volcano Observatory issued a Volcanic Observatory Notice for Aviation. Every aviation authority in the Pacific received it. Every airline flying through Hawaiian airspace received it. Every dispatcher routing trans-Pacific flights received it. The notice confirmed what the tilt meter had already shown. The eruption was over. The fountain had stopped. The plume was dissipating. The aviation color code was dropping from orange to yellow, and buried in the remarks section, the standardized block of capital letters that contains the technical language USGS scientists use to communicate with aviation authorities, was a sentence that has appeared in exactly 0 pieces of coverage about episode 46. Fountain activity in this area unlikely for the next several weeks. 7 words. In 17 months of episodic eruption, 46 episodes, each one forecast in days, each one arriving within the 4-day window the tilt meter predicted, the USGS has never issued a notice saying the next fountain is weeks away. Until now. Something changed on May 5th, something the scientists are tracking and not yet explaining publicly, and the 7 words they chose to communicate it are the most scientifically significant statement in this entire 501-day eruption cycle. Stay with me. Because several weeks sounds reassuring. It sounds like a rest, like the volcano is taking a break. It is not a rest. In the geological record of Kilauea's episodic eruptions, the historical sequences that scientists compare this eruption to, the pauses that precede the largest events are not the shortest ones. They are the longest. And there's a detail inside episode 46's own data, a specific number that appears in the technical USGS summary and has received no coverage, that tells you exactly how differently this episode behaved from every one of the 45 that came before it. That number is 45, the same as the episode count. But in this context, it means something completely different, and it changes the forecast for what several weeks is building toward. First, the number. There were about 45 precursory overflows, including about 24 from the north vent and about 21 from the south vent during the precursory phase of episode 46. CBS News 45, precursory overflows, before the main fountaining began. To understand what that means, you need to understand what a precursory overflow is. In Kilauea's current eruption system, the gas piston mechanism that controls episodic fountaining involves a period before the main event where the magma surface rises slowly, sloshes over the vent rim in small spills, overflows, and then retreats. These precursory overflows are the volcano's dress rehearsal. They release small amounts of gas and lava as the pressure builds toward the threshold that opens the vent system into full fountaining. The precursory phase for episode 46 began at 1:38 p.m. on May 4th. The main fountaining began at 8:17 a.m. on May 5th. That is 19 hours of precursory activity. Low-level dome fountaining from the north vent began at 8:17 a.m. HST and grew in vigor and height. The south vent had one short-lived dome fountain and overflow after the onset of north vent fountaining, and subsequently had periodic gas jetting and flames. CBS News 45, precursory overflows in 19 hours, from 2 vents simultaneously. The most elaborate precursory sequence in recent episodes, 24 from the north, 21 from the south, before the main episode produced only 9 hours of fountaining and then stopped abruptly. That is symmetry. The most complex precursory sequence producing the shortest complete episode is the scientific signature that the several weeks forecast is trying to describe. The system did something unusual on May 4th and 5th. It built up slowly, expressed itself extensively in the precursory phase, and then when the main fountain finally fired, it drained faster than any recent episode of comparable preparation. What does a magma system that expends unusual energy in its precursory phase and then drains rapidly in its main phase look like when it recharges? Nobody has said publicly. The several weeks is the answer, delivered in 7 words. Here's the historical context the USGS is drawing on when it says several weeks. The current eruption cycle has produced 46 episodes in 501 days. The pauses between episodes have ranged from less than 24 hours to approximately 21 days. The average pause has been roughly 10 to 11 days. Several weeks. The language in the May 5th VONA implies a pause of at least 14 to 21 days, possibly longer. The USGS did not specify a number. They chose several weeks deliberately. In the historical record of Kilauea's episodic eruption sequences, the 1959 summit eruption that produced 17 episodes of lava fountaining, the episodic eruptions of the 1960s and 1970s, and the analogous sequences that volcanologists compare this cycle to, the scientific literature is consistent on one pattern. Episodes that follow longer recharge pauses tend to produce higher fountain heights and greater lava volumes. This relationship is not linear, and it is not guaranteed. Shorter pauses can sometimes produce spectacular events, and longer pauses can produce modest ones. But the physics of the gas piston mechanism, the fill-and-drain cycle, creates a general tendency. More time between events means more complete recharge, which means more pressure when the piston fires. Episode 43 set the current fountain height record at 1,170 feet. Episode 43 followed a longer than average pause. The main body of the north vent fountains reached heights of 650 feet during episode 46, with an average effusion rate of 180 cubic yards per second and a peak of 310 cubic yards per second. CBS News, 650 feet. Episode 46, after a 12-day pause from episode 45. If several weeks means 21 days, the longest pause yet in this eruption cycle, and the fill rate returns to the zero. Load 5 to 0. 1 microradians per hour that the Wikahuna tilt meter has been recording. The chamber will be recharged to a level it has not reached since before episode 43. The south vent's behavior during episode 46 adds a specific dimension to this calculation. Here's the detail that should stop you cold. The south vent's one contribution to episode 46 was a single brief dome fountain, an overflow at the very beginning of the main fountaining phase, immediately after the north vent ignited. The south vent had one short-lived dome fountain and overflow after the onset of north vent fountaining, and subsequently had periodic gas jetting and flames throughout the remainder of the episode. CBS News 1. Brief dome fountain. Then gas jetting for 9 hours. The south vent that produced the 1,970-foot record fountain in episode 43. The south vent that produced intense gas jetting and visible flames during episode 46's precursory phase, indicating significant pressurized gas accumulation in the conduit. The south vent that was glowing brightly on webcams during the recharge phase before episode 46 began, causing the USGS to note it was significantly brighter than the north vent. That vent fired one brief fountain at the start of episode 46, and then went silent for 9 hours while the north vent did all the work. Now consider what several weeks of recharge means for a south vent conduit that has been accumulating gas pressure, evidenced by the intense flame jetting during episode 46, that has not fully released that pressure since episode 43. And that now has a recharge window significantly longer than any pause in the recent sequence. The gas that was building in the south vent conduit during episode 46 was still there when the episode ended. It did not fully escape. The north vent drained the chamber, the south vent kept its gas, and now the chamber is refilling. Slowly. For several weeks. Here's the visual scale of episode 46 that no coverage has contextualized. During episode 46's peak at 10 a.m. on May 5th, the USGS photographed something that has never been photographed in this eruption cycle and has not been described in any coverage. The episode 46 plume was photographed rising above the summit caldera of Mauna Loa, Axios Mauna Loa, the second volcano on the Big Island, the largest active volcano on Earth by volume. Its summit caldera sits at 13,679 feet above sea level, nearly 10,000 feet above Kilauea's summit at 4,091 feet. The episode 46 plume reached 20,000 feet above sea level. That means the plume from Kilauea's summit eruption, from vents inside a crater at 491 feet, rose 15,909 feet above the vent, reaching a height nearly 6,000 feet above the summit of Mauna Loa. When you look at the USGS photograph taken on May 5th, you see Mauna Loa in the foreground, the massive, gently sloping shield volcano that defines the southern horizon from high-low, with the Kilauea eruption plume rising behind and above it, not beside it. Above it. The last time Mauna Loa itself erupted was November and December 2022. Its summit caldera sits above the clouds that form around 7,000 to 8,000 feet on most days. The Kilauea plume on May 5th cleared Mauna Loa's summit by more than a mile vertically. That photograph has been published by the USGS. It has received no description in any outlet covering episode 46. Here is what appeared in the May 3rd USGS daily update and has received zero coverage in any reporting on episode 46. Some HVO monitoring network data streams were interrupted this morning, just as this update was about to be published. HVO is working to rectify the problem as soon as possible, and staff continue tracking several unaffected data streams to maintain watch over Kilauea and Mauna Loa volcanoes. Axios. The monitoring network had a data interruption on May 3rd. May 3rd was 2 days before episode 46 began. It was the day the USGS issued the forecast that placed episode 46 between May 4th and 7th. It was the day the tilt meter data was showing accelerating inflation, the accelerating recharge that would produce the 45 precursory overflows starting at 1:38 p.m. the following afternoon. HVO staff continued tracking several unaffected data streams while the others were being restored. The specific streams that were interrupted, whether they included the Wekahuna tilt meter, the SO2 sensors, the infrasound network, are not specified in the published update. The problem was resolved before the episode began. The VONA documentation for episode 46 shows continuous data from the critical instruments throughout the episode. But the May 3rd interruption reveals something specific about the monitoring architecture that no coverage has addressed. The monitoring network that the USGS relies on to issue the 4-day forecast windows that have become Kilauea's signature scientific achievement in this eruption cycle is not immune to outages. The SDH tiltmeter access road has been buried by tephra since episode 43. The monitoring network had a data stream interruption on May 3rd. The USGS describes its monitoring posture heading into episode 47 as advisory, the standard between episode status, while planning for several weeks of recharge. Several weeks of recharge is the longest monitoring window in this eruption cycle. The monitoring infrastructure that will watch that recharge is operating with one buried instrument, a recently restored data network, and a south vent whose gas pressure state is currently unknown. Here is what is not making headlines. The VONA for episode 46's end contained an additional remark that has not been reported alongside the several weeks language. The VONA issued at 3:24 UTC on May 6th stated, "Lava Fountain episode 46 ended at Kilauea Summit. Fountain activity in this area unlikely for the next several weeks. Refer to NWS for information on drifting plume." A WRD do refer to NWS for information on drifting plume. The episode 46 plume reached 20,000 feet and moved northeast. The National Weather Service was tracking it as of the post-episode VONA, not as an aviation hazard at that point, but as a drifting plume of volcanic gas and fine particles, Pele's hair, volcanic ash, moving northeast at 20,000 feet through the Hawaiian airspace corridor that Trans-Pacific flights use, being tracked by NWS weather models that follow plume trajectories. The refer to NWS language appears in VONAs when the eruption is over, but the atmospheric consequences are still in motion. The plume that episode 46 generated was still being tracked by weather authorities after the eruption ended. The drifting plume and its cargo, SO2, fine tephra, Pele's hair, continue to move through the atmosphere after the fountain stops. The health effects of volcanic emission do not have an off switch that coincides with the VONA that lowers the alert level. Volcanic gas, water vapor, carbon dioxide, and sulfur dioxide emissions can remain locally hazardous in the areas immediately downwind of the vents, even when the vents are not actively erupting. Small, glassy volcanic fragments may be remobilized during windy conditions following recent eruptive episodes. Residents and visitors should minimize exposure to these fragments, which can cause skin and eye irritation. WRD view. Even when the vents are not actively erupting. The alert is advisory. The color code is yellow. The eruption is paused. And the gas and tephra from episode 46 are still in the air, on the ground, and on the surfaces of every community that was downwind of a 20,000-foot plume moving northeast on Tuesday. The several weeks of the next episode is not the same as several weeks of safety. Now, the specific scientific question that several weeks creates. Episode 46 produced the most elaborate precursory sequence in recent memory. 45 overflows in 19 hours from 2 vents, and then delivered only 9 hours of main fountaining, entirely from the north vent, while the south vent produced 1 brief dome fountain and then 9 hours of gas jetting. The south vent's gas jetting is documented in the USGS record as producing visible flames at the opening, the ignition of volcanic gases escaping the pressurized conduit. That pressure did not release in episode 46. It is still in the south vent conduit. Over the next several weeks, 2 things will happen simultaneously. The magma chamber will refill, measured by the Wukahuna tiltmeter recovering the 14 microradians, drained during episode 46, and the south vent conduit will continue accumulating gas pressure from the same magmatic source. When episode 47 begins, both systems will be more fully charged than they were when episode 46 began. The north vent will have a full chamber to drain. The south vent will have a full conduit of pressurized gas and weeks of additional accumulation. In episode 43, the last time the south vent produced a major fountain, it reached 1,770 feet, the fountain height record for this eruption cycle. Episode 43 followed a longer than average pause. In episode 46, the south vent produced 1 brief dome fountain and then gas jetting for 9 hours. It did not discharge its conduit pressure. The question that several weeks tomorrow is building toward, and that will be answered by whatever episode 47 produces, is whether the south vent's undischarged pressure accumulated across the longest pause in this eruption cycle produces something that belongs in the same category as episode 43. The USGS has not characterized this possibility publicly. The monitoring data that will reveal the answer is being collected in real time. Now pull back to the analogous eruption sequences that volcanologists compare this cycle to, the 1959 Kīlauea eruption. the closest historical analog to the current episodic summit eruption cycle. It produced 17 episodes of lava fountaining between November 14th and December 20th, 1959. Pauses between episodes ranged from hours to days. The final episode, episode 17, produced the highest lava fountain ever recorded at Kilauea at that time, 1,900 feet, higher than any episode that preceded it in the same cycle. The 1959 sequence followed a pattern that volcanologists now recognize. The later episodes in an episodic cycle tend to be larger as the vent system becomes more established. The conduit geometry optimizes for efficient magma transport, and the accumulated recharge capacity of the magmatic system builds toward a climax event. The current eruption cycle has produced 46 episodes since December 23, 2024. Episode 43's 1,770-foot south vent fountain exceeded all previous episode heights in this cycle. It was the 43rd episode in a cycle whose historical analog climaxed in its 17th. If the 1959 Kīlauea ERUPTS pattern holds, if the largest events tend to come later in a cycle, then the current eruption cycle is not in a terminal decline. It is in the middle third of a sequence that may continue for years, the several weeks. Vona language does not indicate the cycle is ending. It indicates the recharge phase before episode 47 is longer and more complete than any previous recharge in this sequence, which means episode 47 enters the system with more stored energy than any previous episode since episode 43. The tilt meter will tell us when the threshold is reached. The Vona will tell aviation authorities. The County Civil Defense will issue the advisories. The 7 words in the Vona are the first data point in that calculation. Several weeks. So ask yourself 3 questions. The Vona issued after episode 46 stated that fountain activity is unlikely for the next several weeks. The first multi-week pause forecast in 501 days of episodic eruption. Every previous episode in this cycle has been forecast in days, not weeks. The several weeks language appears in the aviation notice, a document written for flight dispatchers, not for the public. It has not been explained in a USGS press release, a Volcano Watch article, or any public communication in terms that describe what happened scientifically during episode 46 to produce a forecast that breaks 17 months of day-scale timing. What specific measurement, tilt meter rate, SO2 emission, conduit pressure indicator, produced the several weeks assessment? And why has that explanation not appeared in the public record? WRD BWW. Episode 46 produced 45 precursory overflows in 19 hours before the main fountaining, including 24 from the north vent and 21 from the south vent. The south vent then produced 1 brief dome fountain at the episode's onset and 9 hours of gas jetting. It did not discharge its conduit pressure in any sustained fountaining event despite extensive precursory activity. The south vent's undischarged conduit pressure, evidenced by 9 hours of visible gas jetting flames, is now entering a several weeks recharge period simultaneously with the magma chamber recharge tracked by the tilt meter. If the south vent's gas pressure and the chamber's magma recharge reach their respective thresholds at similar times during episode 47's onset, and if the south vent fires with the same conduit pressure state that produced 1,170 feet in episode 43, plus several additional weeks of accumulation, what is the current HVO assessment of the south vent's contribution to episode 47? And has that assessment been shared with Hawaii County Civil Defense? CBS News. And if the USGS monitoring network experienced a data stream interruption on May 3rd, 2 days before episode 46 began during the accelerating recharge phase, and the SDH tilt meter access road remains buried under tephra from previous episodes, and episode 47 is now forecast on a several weeks timeline, the longest monitoring window in this eruption cycle, at what point does the reconnaissance for new monitoring stations mentioned in the April field work calendar produce installed operational instruments? And how does the current monitoring capacity, 1 available primary tilt meter, a recently restored data network, and 1 site, Specific Yellowstone, track a south vent conduit whose pressure state is currently undetermined across a multi-week recharge window? Right now, as you read this, the Wekahuna tilt meter at Kilauea's summit is recording positive tilt. The magma chamber is refilling. 14 microradians were drained during episode 46. The chamber needs to recover those 14 microradians before the USGS forecast threshold for episode 47 is reached. At the 0.05 to 0, 1 microradians per hour rate that the tilt meter has recorded during recent recharge phases, that recovery takes 140 to 280 hours, 6 to 12 days. That is the lower bound of several weeks. But several weeks is not a lower bound. It is an assessment. It means the scientists watching the tilt meter expect something to change, the recharge rate, the conduit behavior, the system dynamics, that will extend the timeline beyond what the chamber volume alone would predict. The alert level is advisory. The aviation color code is yellow. All eruptive vents and lava flows are confined to Halemaʻumaʻu crater within Hawaii Volcanoes National Park. WRDW advisory, yellow, confined. Those 3 designations are correct. The crater floor holds 6 million cubic meters of new lava from episode 46, cooling and solidifying into the foundation for episode 47. The south vent is dark. No flames today, no gas jetting. For the first time since before episode 46 began. The north vent is dark too, and in the south vent conduit, 9 hours of accumulated gas pressure that never turned into a fountain is doing what pressurized gas in a volcanic conduit does. It waits. The episode 46 Plume rose above the summit caldera of Mauna Loa. Axios. That photograph exists. A volcano erupting at 4,091 feet. Its plume clearing the summit of Earth's largest active volcano at 13,679 feet by nearly a mile. The scale of what Kilauea produced on May 5th measured not against anything human, but against the second tallest mountain in the Pacific. And it happened from 2 vents inside a crater inside a national park. The next time those vents fire, the pause will have been the longest in 501 days. The south vent will have had weeks to build toward whatever it does in episode 47. The tilt meter will record the moment the threshold is crossed. The Vona will go out. And somewhere in the several weeks between now and then, the question that 45 precursory overflows and 9 hours of gas jetting in 7 words in an aviation notice are collectively asking will begin to find its answer.